Hello students, I am Rashika. I have done MSc in Physics and I have qualified the CSIR NET and JRF exam in Physics and the GATE exam in Physics with a percentile of 99. Students, from today I am starting a new video lecture series for class 11th as per the CBSE syllabus. In this series I will try to cover all the topics as per the NCERT. I hope you will learn from my videos and my videos will be helpful for you all. So let's get started. We are about to learn physics. So before entering into the beautiful world of physics, let us try to know a little about this world, a little introduction about the beautiful world of physics, which is our first chapter, that is physical world. Students, we all must have heard the name of the very famous physicist Albert Einstein. Albert Einstein once said that there are two ways to live life. One as though nothing is a miracle and the other as though everything is a miracle. I think it's a very meaningful quote. Here he is trying to basically emphasize upon the way in which we look at life, which makes all the difference. For one person, the same thing can have a lot of meaning in itself, it can be a wonder and it can be a miracle, and for the other it cannot be anything at all. It is our way in which we look at the things which makes all the difference in our life. Now students, everything which we see around us, like the sunrise, the sunset, the four seasons which are distributed at the regular intervals over the period of a year, the rainbows, the rainfall, the tides, volcanoes, everything is a wonder. And human beings have always been very imaginative and very curious to know about the world around them. And one of the ways or one of the responses of this curiosity towards the physical world is to observe everything very carefully, right? And then to find out the relations, the rhythms, the patterns which are existing in the physical world, in the physical phenomena, and then build the tools with the help of which we can interact with the nature better, right? So this basically is science. All right, we see the things around us, we try to observe them, and when we try to interact with them. Students, if you would have got the opportunity to look at a child 1 or 2 years of age, even at such a young age, just entering into the world after the birth, the child is so curious to know about the world around him or her. Whenever he sees things around him and he is in the condition to move or crawl or walk, he'll quickly rush towards everything that he can see. He'll roam about the entire house and pick up everything, move everything, and just whenever any sound is coming, he'll quickly try to listen from where the sound is coming and then move towards that side. So basically this curiosity has been given to us by God in default, and we must be very thankful to God for making us like that. Students, science is as old as the human species. Many early civilizations like the ones in India, China, Mesopotamia, Greece, Egypt have contributed a lot to its growth and development. From 16th century, great strides were made by Europe, and by the 20th century, science became almost like an international enterprise where many different cultures and civilizations were contributing to its growth and development. For example, if you look at mobile phones, students, we all in today's age are familiar with the mobile phones, right? But the form in which we see the mobile today has been a result of a lot of effort, a lot of thought, a lot of perseverance that has been put on into it by many humans, by many scientists, by many thinkers, inventors over a period of years, right? So let's just try to understand it with a little example. First, let's understand what a telephone is. Students, we all also know about the telephone very well. So what happens in the case of a telephone? In the case of a telephone, the sound, which is basically the human voice, is converted into the electronic signals, and these electronic signals are transmitted via the cables or some other communication channel to the other telephone, where it is reproduced in the form of the sound by the receiving user. So this is what happens in the case of a telephone. Now after the invention of telephone, the scientists thought, the inventors thought that why not replace this cable or communication channel by a wireless communication so that our phone becomes very handy. We can carry it anywhere where we go, and that's why the name mobile, right? So this is basically the general technology which is used in the case of the mobile phones, and this wireless communication is basically in the form of the radio waves, right? So see how the mobile phones have evolved from the telephone, which was invented by Alexander Graham Bell, to the mobile phones, and today we have lot many things, lot many inventions. We have the internet, we have the GPS system. I mean, it's so useful to the humankind. It has got great help to the humankind. So this is what science does. Let's try to find out more about science. I'll first write a small definition about science, students. First of all, that science comes from a Latin word, scientia, which means to know, right? Now exploring, experimenting, and predicting. What we see around us is science. Explore means we try to find out what is happening by observing it very carefully. Experimenting means we try to perform the experiments to find out the reason behind them, and then we predict the theories which could explain the phenomena very well. So exploring, experimenting, and predicting what we see around us is science. Students' curiosity to learn about the world, unraveling the secrets of the physical world, is the first step towards the discovery of science. Now, the science basically involves a procedure, a step-by-step method which is basically adopted so that we can understand about our physical world, the physical phenomena which is happening in a very better way, in an accurate way. And that method is called as the scientific method. And with the help of this scientific method, we arrive at a scientific theory. Right. Now let us discuss the steps of the scientific method first of all, and then we will study about the scientific theory. Students, first I will write down the steps which are involved in the scientific method, and then I'll discuss it one by one. Students, scientific method basically involves the 5 steps: detailed observation, controlled experiments, qualitative and quantitative reasoning, mathematical modeling, prediction and verification of the theories. Now, what is detailed observation? Observation, first of all, means to observe, to see, to look at something very, very carefully. And detailed observation means that trying to observe each and every detail of a particular physical phenomena which is happening. For example, if I have to write down a detailed observation about the appearance of the rainbow in the sky, then what do I say? I say that it was raining and there was sun in the sky at the same time, and then I was able to observe an arc, colorful arc which comprises of 7 colors in so and so pattern, in so and so sequence, with red being at the top and violet color being at the bottom. Let me just write it down. There was rain and sun in the sky at the same time, and then I was able to observe an arc of 7 colors with red at the top and violet color at the bottom in the pattern of Vibgyor, right? So this is kind of an observation. For an example, we are saying that we can make about the appearance of the rainbow in the sky. Now, controlled experiment. Controlled experiment means that we repeat the same procedure. We try to perform the same procedure in our laboratory in a controlled environment, which means that everything is in our control, we can vary the situations of the experiment, and then we can observe the different results, which means that if we have to perform the experiment of the appearance of the rainbow in the sky, then what do? I'll take a source, I'll take water in a flask, in a glass, in a tumbler, anything, and then I'll try to pass the light through it, and I'll be observing whether I'm getting a rainbow or not. Now what I can vary in this, I can vary the light which I'm using, right? I can vary, like for example, in the case of the water in a glass, I can use bubbles, and then I can see if I'm getting the same phenomena, I'm getting the same color kind of the pattern or not. So this is basically the controlled experiment in which everything is in the control of the person who is performing the experiment. He can vary the conditions, he can vary the factors, the parameters, and then the results will be dependent upon that. Now qualitative and quantitative reasoning. Qualitative basically means the logical reasoning, and quantitative means the mathematical reasoning. What is reason? Reason means that why anything is happening, we try to find out. So in the qualitative reasoning, we try to find it out logically, and in the case of quantitative reasoning, we try to find it out mathematically. Now logically means that all the knowledge which we have, whatever experiences we have, whatever we have read, on the basis of that we try to question that why the so and so things we are getting, right? In the case of the rainbow, what we can say that why when the rain and the sun are in the sky at the same time, why only that time we are getting this pattern, and why only this pattern, why not some other pattern, right? In the quantitative reasoning, the quantities which are involved in the experiment, I'll try to find a relation between them which can answer the questions which are appearing in my mind, that yes, this is the reason why my experiment, why my phenomena is happening. And what happens that both of them are most of the times in accordance with each other, right? For example, in the case of the quantitative reasoning, the quantities involved are the wavelengths of these colors and the deviation. So what I can say, that since the red color has got a maximum wavelength and the violet color has got a minimum wavelength, that is why this color undergoes the least deviation and this color goes the maximum deviation, right? This is what I can say quantitatively. Now mathematical modeling means, it is basically in continuation to the quantitative reasoning. We first of all think about a model, like a conceptual model, and then when we use the quantities which are used in that experiment, the values or say the mathematical terms which are used in that experiment, and then we create a model on the basis of that, then we get a mathematical model. So mathematical model basically is kind of a derivation of the formula with the help of the quantities involved in a particular experiment, so that that formula completely describes our experiment. We can obtain the accurate results by putting on the values, and these also can be used in the future times whenever we are building something new on the basis of that phenomena, right? For example, we are aware with the formula of the law, we are aware with this formula, right? F is equal to G m1 m2 upon r square. Now by looking at this formula, simply I can say that this is the law of gravitation, right? What is happening here, that the force which is acting between the two bodies, or we can say that the two bodies attract each other with a force which is directly proportional, which is equal to the product of the masses and inversely proportional to the square of the distance between their centers. And first was the proportionality, then we arrived at a constant which is the gravitational constant by putting certain values, and then we were able to derive this formula, right? So this is mathematical modeling. Now prediction and verification of the theories. Prediction, as we know, predicting something, assuming something, that yes, this could be the reason why this experiment is happening, why this phenomena is basically happening. And verification means that we check that yes, this is happening, this is the reason that it is happening. We have predicted the theory, now we'll check that whether this theory is applicable in every case or not. For example, in the case of the rainbow, the theory behind the appearance of the rainbow is, it is the dispersion of the light, right? So we say that dispersion of the light is the theory, and then we'll check whether it is accounting for it or not. So this is basically the scientific method. Now with the help of this scientific method, at the end we arrive at our scientific theory. Right. Now let us try to learn about the scientific theory. There are certain steps also involved in the evolvement of a scientific theory. Right. So let us try to find out. Students, many a times we have heard that nothing in this world is permanent. Everything is undergoing change, and so is science. Science is ever dynamic. There's no theory in science which can be considered as a final theory, and there's no unquestioned theory among the scientists. Let me first write down and then I'll explain it more. As the observations improve in details and the experiments yield new results, existing theory is modified to account for it, which means that as our experiments yield more and more details, have got more and more details in themselves because of the improvement of the technology, because of the better equipments and many more reasons, and the experiments yield new result, which means that we perform an experiment and we are getting the results which we have not obtained earlier, right? So on the basis of those observations and results of the experiment, sometimes what happens is that our existing theory is not able to account for all of these observations and results accurately, which means that some kind of the modification have to be done in the existing theory to account for our results and observations. So let us try to understand it with the help of an example. Students, there was one astronomer and mathematician. He's also called as the father of modern astronomy, Nicholas Copernicus. So Nicholas Copernicus basically assumed the planetary circular orbits in heliocentric theory, which means that he assumed that the planets move in the circular orbits around the sun, with the sun being at the center of the universe, right? Which is called as the heliocentric theory. There was another scientist who collected some extensive data upon the motion of the orbits, right? And there was another person called Johannes Kepler, another scientist called Johannes Kepler. We'll study the Kepler's laws later on. So he examined the data collected by Tycho Brahe, and on the basis of that examination, that analysis, he realized that in order to fit the data better, the orbits must be elliptical and not circular. So from here we see, students, that how the things are so interconnected, right? They are so linked with each other. There was one who assumed that the orbits must be moving in the circular orbit. There was another one who collected the data on that, and there was third one who studied that data and then gave the modification in the first theory which was given in the first suggestion which was made, right? So this is how a scientific theory is modified. All right. Now second thing is that sometimes what happens is that the existing theory is not at all able to explain about the new observations, and then leads to some major upheaval in science. We know the Newton's laws of motion. We have a little idea about the Newton's laws of motion. The Newtonian mechanics is based upon the Newton's laws of motion, and the Newtonian mechanics was not at all able to explain even the basic features of the atomic phenomena. The third thing is that, students, sometimes the new experiment suggests some alternative theoretical model, which means that some new experiments were performed, and those experiments as a result suggested an alternative theoretical model after performing all the steps of the scientific method which we discussed a little earlier. And what happens that sometimes theoretical advancement, which means that some kind of the theoretical improvement in the theoretical knowledge, leads or suggests that what to look for in an experiment. Let us try to understand it with the help of an example. Students, in 1930 there was a physicist called Paul Dirac. So Paul Dirac suggested the concept of an antiparticle. Now what is antiparticle? Particle, for example, is an electron, right? Now what is an electron? An electron is a negatively charged elementary particle which has got a charge of 1.6 into 10 raised to the power minus 19 coulomb, and which has got a mass of 9.1 into 10 raised to the power minus 31 kg. This is an elementary particle called electron. Now he gave the concept of a particle which is absolutely identical to the electron except for the fact that it is positively charged, right? Which means that both of them are capable of cancelling each other completely, right? So he gave the concept of antiparticle in 1930. Now 2 years later there was another scientist called Carl Anderson who ended up in discovering the antiparticle. So there was one who gave a theoretical advancement and there was another one who knew that what he has to look for in an experiment, and he ended up at eventually finding out that that particle, right? So these are the 3 basic steps which are involved in the evolvement of a scientific theory. Okay, so students, we have got a little idea about science, the scientific method and the scientific theory. Now physics basically comes under the natural science, right? It comes under the category natural science. Natural science, what does that mean? As the name suggests, study of everything which is present in the nature is natural science, right? It involves 3 disciples: physics, chemistry and biology. Here we are concerned with physics. What is physics? Physics basically comes from a Greek word which means nature, right? It means nature. Now physics in bhautiki in Sanskrit is written as bhautiki. And what is the meaning of bhautiki? Bhautiki means the study of physical world, right? This is a little introduction about physics. Let us write a small definition about physics and then I'll explain it. Now physics is the study of the basic laws of the nature and its manifestation in the different physical phenomena, which means, student, there are certain laws and concepts which govern the different physical phenomena, which sometimes it can happen that there is a single basic law which can govern many different physical phenomena spread over a wide range. So we have to discover those laws, we have to study those laws, which means that it is basically present in the nature. We don't create anything new. It is already existent. We just unravel it or we just discover it. That is physics. And then what do? We try to find out the manifestation, its manifestation in the different physical phenomena. What is the meaning of manifestation? Manifestation basically means, in literal terms, an event which clearly shows something theoretical. Means we were able to find out the basic laws of the nature on the basis of our experiments and everything which we studied, and then we were able to find out, we were able to relate that yes, this basic law is clearly defining, is clearly explaining why a particular physical phenomena is happening. That is physics, right? For example, we know that Newton's laws of gravitation, Newton's law of gravitation, this Newton's law of gravitation describes the fall of an apple on a ground. Right? It is said that Newton was sitting inside an apple tree and then an apple fell down, and from there he got an idea about why this apple is falling down, and he got the idea about the gravity. Alright, now this Newton's law of gravitation describes the fall of the apple on the ground, and this same Newton's law of gravitation also describes why the planets move around the sun. And why the moon moves around the earth. So you can see the diversity, you can see the range here, that the same law is able to explain why the simple thing, an apple is falling on the ground from a tree, and such a great phenomena of the universe, that why the planets are moving around the sun, why the moon is moving around the earth. So there are a few laws, there are a few concepts which describe a wide range of the phenomena, right? So this is physics. What are the two principal thrusts in physics? What is the meaning of thrust? Thrust basically means to push something in the forward direction very violently, right? If you push something very violently in a particular direction, then it is bound to move ahead in a long way, right? So these two thrusts basically help physics go a long way, right? To sustain itself, to go a long way in a particular direction, in a particular forward direction. Now these two thrusts are, number one is unification, and number two is reductionism, right? Now let us study about these two. Now unification, as the name implies, unification means to combine two things, or to combine here in the sense to combine two theories, so that the combined theory is able to explain, is able to account for a wide range of the physical phenomena, which means that our theory becomes a little concise by combining them, but the range of the phenomena which is covering becomes more diverse, right? And also it helps to explain the things more easily, which means that the simplification also becomes a little easier with the help of that. Example of this: the basic laws of electromagnetism Example of this is the basic laws of electromagnetism, that is the Maxwell's equation, explain both the electric and the magnetic phenomena, all the electric and magnetic phenomena very well, right? Alright, so this is unification. Now let us understand what is reductionism. Now students, in today's time, in today's COVID time, we all are aware with the concept of making a kadha, making of herbal tea, right? So what do we do when we make a herbal tea? We add all the ingredients in say 2 cups of water, and then we reduce it to a quantity of say 1 cup, so that all the goodness of all those ingredients is basically comes into a single cup. So reductionism, as the name suggests, is reducing something. It is an attempt in which we try to explain the properties of the bulk systems in the terms of the properties or the interactions of its constituent simpler particles, right? Simpler parts. For example, thermodynamics we have, we'll study thermodynamics later. So in the thermodynamics, the properties of the bulk systems are explained in terms of its macroscopic quantities like the temperature, entropy, internal energy, etc. And here basically we attempt to derive, the properties of the bulk systems in terms of the properties and interactions of its constituent simpler parts. So students, these were some of the topics which were covered today. Some topics will be covered in the next video lecture. I hope my video was helpful for you all. You were able to learn from it. So do join the next class.